What if the biggest problem in modern farming could become its most powerful solution? Every year, massive livestock farms produce millions of tons of waste, releasing harmful methane gas and polluting our water. But what if we could turn that waste into clean, reliable electricity? Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we're re-exploring how next-generation biogas technology is transforming livestock manure into a powerful source of renewable energy. The global challenge of livestock waste is staggering. Modern livestock farming, with its immense scale, generates enormous volumes of waste, including manure, urine, and various byproducts. For a large-scale dairy or pig farm, this can easily amount to millions of tons annually. When this waste is left unmanaged, it becomes a significant environmental threat. It emits methane, one of the most potent greenhouse gases, which has a warming potential over 25 times that of carbon dioxide. Furthermore, runoff from waste lagoons pollutes nearby water systems, and the foul odors can create serious health hazards for surrounding communities. In response, governments and environmental agencies are increasingly demanding effective and sustainable solutions. Instead of viewing this massive amount of livestock waste as a liability, innovative thinkers are turning it into a valuable asset. This is where the concept of turning waste into energy comes into play, and biogas technology is at the forefront of this revolution. Biogas systems don't just solve a disposal problem, they transform agricultural byproducts into a multifaceted resource. The process generates clean electricity, provides sustainable heat for farm operations, and produces a nutrient-rich organic fertilizer. This approach perfectly aligns with the principles of a circular economy, effectively closing the loop by converting waste back into energy and valuable agricultural inputs, all while significantly reducing environmental damage. The science behind biogas technology is rooted in a natural process called anaerobic digestion. In simple terms, this is what happens when microorganisms break down organic matter like manure and agricultural slurry in an environment completely devoid of oxygen. As these microbes feast on the waste, they release a mixture of gases, primarily composed of methane and carbon dioxide. Methane is the crucial energy component, chemically similar to the natural gas we use for heating and cooking. This captured methane can then be combusted to generate clean electricity, making it a powerful renewable energy source. A typical biogas system consists of several key components working in concert. The heart of the operation is the digester, a large, sealed, and often insulated tank where the anaerobic digestion process takes place and microbes get to work breaking down the waste. As the gas is produced, it is captured by a gas collection system, which prevents the potent methane from escaping into the atmosphere. Finally, the captured biogas is channeled to a power generation unit, such as a generator or turbine, which efficiently converts the gas into usable electricity and heat, ready to power the farm or be sold to the grid. While the concept of biogas is not new, there's a world of difference between traditional and next-generation systems. Early, traditional digesters were often plagued by low efficiency, inconsistent gas yields, and high maintenance requirements, making them less practical for many farmers. In contrast, modern next-generation systems have overcome these limitations. They incorporate advanced insulation to maintain optimal temperatures, utilize sophisticated microbial management techniques to boost efficiency, and feature automated controls that maximize methane production. These advanced systems also reduce operational downtime and are designed for seamless integration with modern power grids. To fully appreciate the innovation of biogas, it's important to understand the severe problems associated with conventional waste management. The most common method involves storing manure in open lagoons or large piles. As this waste decomposes naturally in the open air, it releases enormous quantities of methane directly into the atmosphere. Since methane traps over 25 times more heat than carbon dioxide over a 100-year period, these emissions are a major driver of global climate change. This practice essentially turns farms into unintentional sources of powerful greenhouse gases. Beyond air pollution, conventional waste management poses a serious threat to water and soil health. During heavy rains, waste runoff from open lagoons can easily contaminate nearby rivers, lakes, and crucial groundwater sources. This runoff is laden with high concentrations of nitrogen and phosphorus, which leads to a process called nutrient overload. This overload triggers harmful algal blooms that deplete oxygen in the water, resulting in fish kills and rendering the water unsafe for drinking or recreation. Over time, the soil can also become degraded from an excessive buildup of these same nutrients, harming its long-term fertility. Furthermore, leaving this waste unmanaged represents a significant economic loss. Livestock manure is not just a pollutant, it contains valuable nutrients and untapped energy potential. By failing to capture this potential, farmers miss a golden opportunity to produce their own electricity, drastically reduce their spending on synthetic fertilizers, and even create new revenue streams. By treating waste as waste, they are discarding a resource that could bolster their financial resilience through the sale of surplus energy or by earning valuable carbon credits. Next-generation biogas technology directly addresses these challenges with a suite of sophisticated improvements. Advanced digesters are engineered for maximum efficiency, operating at consistently optimal temperatures to keep microbial communities thriving. Many systems now employ specialized, highly productive microbial cultures and incorporate pre-treatment methods to break down the tough fibers in waste more quickly. This meticulous management results in a significantly higher biogas output per ton of waste, making the entire process more productive and profitable. At the core of these modern systems is the integration of smart monitoring and automation. A network of sensors continuously tracks critical parameters inside the digester, such as pH levels, temperature, gas composition, and internal pressure. This real-time data is fed into automated systems that can instantly adjust conditions to maximize efficiency and proactively prevent system failures. This level of control means farmers can remotely monitor their entire biogas operation via a mobile app, receiving alerts and performance reports from anywhere, at any time. The benefits extend beyond the farm gate, as these systems are designed for integration with renewable energy grids. Electricity generated from biogas can be fed directly into the local power grid, providing a stable source of clean energy for the wider community. Some forward-thinking farms are even establishing their own microgrids, combining the consistent power from biogas with intermittent sources like solar or wind. This allows them to power not only their entire farm operation but also to supply energy to surrounding homes and businesses, enhancing local energy independence. A major financial incentive for adopting this technology is the opportunity to earn carbon credits. By capturing methane that would have otherwise been released into the atmosphere, farmers are actively reducing greenhouse gas emissions. This reduction qualifies them for carbon credits under various international and national programs. These credits can then be sold to corporations or other entities that need to offset their own carbon emissions, creating a valuable new revenue stream and making the farm a key player in the global fight against climate change. The benefits of biogas-based electricity are numerous and far-reaching. First and foremost, it directly tackles climate change by reducing greenhouse gas emissions. Capturing methane at its source significantly lowers a farm's carbon footprint, helping nations meet their climate targets under international agreements like the Paris Accord. It turns an environmental liability into a climate solution. Secondly, biogas provides a source of renewable electricity that is exceptionally reliable. Unlike solar and wind power, which are dependent on weather conditions, biogas generation is continuous. It can produce power 24 hours a day, 7 days a week, making it a stable and dependable renewable energy source that strengthens the resilience of the power grid. For the farmer, one of the most immediate benefits is the reduction in farm energy costs. Farms are energy-intensive operations, requiring electricity for equipment, lighting, heating, and refrigeration. By generating their own power from waste, farmers can significantly reduce their dependency on expensive fossil fuels or electricity purchased from the grid, leading to substantial long-term savings. Finally, biogas technology is a perfect example of the circular economy in action within agriculture. These systems don't just produce electricity, they also generate a nutrient-rich byproduct called digestate. This substance is an excellent organic fertilizer that can be used to enrich the farm's soil, replacing the need for synthetic chemical fertilizers. This closes the loop, cycling nutrients from waste back to the land, and creating a truly sustainable farming system. Successful implementations of this technology can be seen all over the world. In the United States, large-scale dairy farms in states like California and Wisconsin are at the forefront, using advanced biogas systems to power their operations and sell surplus electricity back to the grid. Initiatives like the California Dairy Digester Research and Development Program have already been credited with preventing millions of tons of COI equivalent emissions. In Canada, government incentives are actively supporting farmers in adopting biogas technology. Projects in provinces like Ontario and Quebec demonstrate how even small to medium-sized farms can profitably generate their own electricity, while simultaneously reducing their waste management costs and environmental impact. In Australia, where remote cattle stations and pig farms often lack reliable access to the central power grid, biogas has become a lifeline. These systems provide a dependable energy source, reducing the reliance on expensive and polluting diesel generators, which in turn lowers both operational costs and emissions. Meanwhile, in the United Kingdom, biogas is being integrated into the national energy strategy. A growing number of biogas plants now supply clean electricity to thousands of households. supported by government policies like renewable energy feed-in tariffs that encourage investment in sustainable energy sources. Looking ahead, the future of biogas is even more exciting, with innovations poised to expand its capabilities. Researchers are developing systems that can produce multiple high-value products from a single stream of waste. Future biogas facilities may not only generate methane for power, but also produce green hydrogen for fuel cells and biochar, a carbon-rich substance that dramatically improves soil health. This multi-product approach will maximize both the economic and environmental benefits. The role of artificial intelligence and the Internet of Things (IoT) will also become increasingly crucial. AI algorithms can be used to predict maintenance needs, optimize the delicate balance of microbial communities within the digester, and ultimately increase the energy yield. A network of IoT sensors will provide the data needed for this level of precision, fully integrating the biogas system into a data-driven, smart farming ecosystem. Ultimately, biogas has the potential to play a critical role in achieving net-zero energy goals. As nations around the world push for a transition away from fossil fuels, biogas offers a unique 3-in-1 solution. It reduces potent methane emissions, generates clean, reliable power, and displaces the need for fossil fuels, helping both farmers and governments achieve their ambitious sustainability targets. Next-generation biogas technology is a true game-changer. It takes one of the most significant waste problems in modern agriculture and masterfully converts it into a clean energy solution. It's a technology that empowers farmers, benefits communities, and helps nations achieve their environmental and economic goals simultaneously. For farmers, this technology opens the door to lower operational costs, new income streams, and a powerful sustainability credential. For investors, it represents a chance to get in on the ground floor of one of the fastest growing and most impactful renewable energy markets. If you believe in the future of clean energy, don't forget to subscribe, leave your questions in the comments, and share this video. Together, we can build a cleaner, more sustainable world.